To explain geometric postulates, let's get some basic vocab out of the way. What is a line? It can extend infinitely in either direction and has an infinite number of points. Postulate 1 says that any of these points can be given the values of 0 and 1. Continue labeling points this way with equal distances between integers. The distance between any two points is the absolute value of their difference. Absolute value means to disregard whether the value is positive or negative. For example, the difference between the points -4 and -2 is -2. But we just want to know the distance, which is simply 2. To explain postulate 2, we zoom in on a line segment called AC. If we put a point called B anywhere on the line segment, the distance between points A and C is equal to the sum of A to B and B to C. In postulate 3, we're going to look closer at this segment, AD. Remember that a ray has a starting point and extends infinitely in one direction, not both. We're going to call the starting point of our rays O. Remember also, a circle contains 360 degrees, so the half circle on one side of this line equals 180 degrees. Let's make point A correspond with 0 degrees and B correspond with 180. Now if we draw two more rays, let's call them P and Q. We can find the angle these new rays form with the point O by finding the difference between them. We use the absolute value again because the measures of angles do not have negative values. For example, the ray OP corresponds with 60 degrees and OQ corresponds with 130 degrees. The difference between them is 70, which is a measure of the angle. To check your answer, remember that the total of all these angles in the half circle need to equal 180. The white space between OA and OP equals 60, and the space from OQ to OB, 180 minus 130, equals 50. Postulate 4 looks closer at an angle. Let's label the points A, O, and C. If we draw a ray from O to any point that we label B, the measure of angles AOB and BOC will equal the measure of angle AOC. If the points A, O, and C fall on a straight line, the angle AOC will end up equaling 180 degrees. Postulate 5 explains that a line is composed of at least 2 points. A plane is a two-dimensional figure with at least 3 points that are not all on the same line. A space is a three-dimensional figure with at least 4 points that are not all on the same plane. Postulate 6 says that through any 2 points, there is exactly one line. Postulate 7 says that through any 3 points, there is at least one plane. If not all 3 points are on the same line, there is exactly one plane. Postulate 8 says that if a line connects any 2 points on a plane, the line itself is on that plane. Now, remember that the place where 2 lines intersect is a point. Postulate 9 says that if you have 2 planes that intersect, their intersection is a line. In Postulate 10, we will look at 2 parallel lines, lines that can go on for an infinity in either direction without ever intersecting. Let's draw a transversal, a line that cuts through at least 2 other lines. Postulate 10 says that these angles that are formed when you do this will be congruent, like these and these. Postulate 11 says the same thing as Postulate 10, but in reverse. If a transversal cutting through 2 lines creates congruent angles, this proves that the lines are parallel. Postulate 12 is also called the SSS, or side-side-side postulate. If 2 triangles have 3 pairs of congruent sides, the triangles themselves are congruent. Postulate 13 is also called the SAS, or side-angle-side postulate. If 2 triangles share 2 congruent sides and a congruent included angle, the angle where those 2 sides meet, then those triangles are congruent. Postulate 14 is also called the ASA, or angle-side-angle postulate. If two triangles share two congruent angles and a congruent included side, the triangles are congruent. Postulate 15 is called the similarity postulate. Remember, while congruent means that two shapes are identical, similar means that they have the same angle measures and proportions, but not necessarily the same lengths. This postulate says that two congruent angles are proof that triangles are at least similar. Postulate 16 looks at arcs, which are segments of a curve. They are often segments of a circle. The sum of two adjacent arcs, AC and CB, equal the full measure of arc AB. Postulate 17 looks at squares. The area of the square equals the length of any side to the second power, or S squared. Postulate 18, the area congruence postulate, states that two congruent figures have equal areas. Postulate 19, the area addition postulate, says that to find the area of irregular figures, one can break them down into non-overlapping parts and add the areas of these parts to find the total area. And that's it. That's the end.